Okay, here we go. 5-4 special quadrilaterals. We are going to talk about a bunch of different quadrilaterals. We've been talking a lot about parallelograms already, and we know that parallelograms have opposite sides that are parallel. Okay, just keep that in mind. That'll come up again probably. Okay, first let's talk about a rectangle. I've got one drawn in here. Rectangle ABCD. Here's some rules that go along with that. A rectangle, it's got 4 right angles. Along with that, it's a parallelogram. So you've got 4 right angles, and because of that, opposite angles are congruent, so that makes it a parallelogram. Remember that? Okay, now there's a theorem that goes along with this. You've seen I've drawn in diagonal AC. If I draw in another diagonal, DB, here's the theorem that goes along with that. The diagonals of a rectangle are congruent. How about that? Okay, going on, here's a rhombus. In a rhombus, you've got 4 congruent sides. So this is congruent to this, is congruent to this, is congruent to this. If you've got 4 congruent sides, you're a rhombus. Guess what? It's a parallelogram, right? Because opposite sides are congruent, and if opposite sides are congruent, then you are a parallelogram. Now, there's some theorems that go along with this. There's actually 3. So the first one says that the diagonals are perpendicular. So if we were to draw in these diagonals here, if you've got a nice drawing and things are lined up right, you'll notice that these are perpendicular. So they form right angles in there when they intersect in the middle there. Okay, another theorem that goes along with that one, each diagonal bisects its angles. So looking up at the top here, this angle is bisected. So those are congruent to each other. And then down here, these are congruent to each other because that diagonal is bisecting that angle. And finally, if 2 consecutive sides of a parallelogram are congruent, then it's a rhombus. Okay, so let's look at this one. Let's draw in a new thing here. Let's say that I give you this parallelogram, okay? I don't know if it's a rhombus yet or not, but if I tell you that's a parallelogram, and then I tell you that this side and this side are congruent, those 2 consecutive sides, then for sure we know it's a rhombus. We sure know that all 4 sides are congruent, and all the other rules, that the diagonals are perpendicular, diagonals bisect the angles, all those things. So if the only 2 things you need, well, you need it to be a parallelogram, and then you need the 2 consecutive sides to be congruent. If that's true, you've got a rhombus. Okay. Now square, I love squares. You've got 4 right angles, and 4 congruent sides. So this is everything. It's a parallelogram, it's a rectangle, it's a rhombus, all of the above. So if we drew in diagonals, the diagonals would bisect each other, they would be congruent, they would bisect the angles, they would form right angles in the middle, all those things, all those rules. There it is. So if you can recall all those rules from a parallelogram and all those rules from a rhombus and a rectangle, they all apply to a square. All right. Now, one last theorem I want to show you. You don't have to write this down, but we're going to start with the right triangle ABC. Okay, so it's got a right angle there. And here's what I'm going to do. I'm going to draw in AD and DC. So I formed a parallelogram. Now remember, this was a right angle, and I formed it with just another right angle on top. So all of a sudden we've got a rectangle. I draw in another diagonal, BD. Okay, so is everybody with me so far? Now what I'm going to do is ask myself, are the diagonals congruent? Well, I made a parallelogram, I made a rectangle, so the diagonals are congruent. Do they bisect each other? Well, it's a parallelogram, so they do. So I've got all of these segments congruent. So what does that really mean? Well, let's go back to the right triangle. What that means is, when I drew this line from the right angle of the right triangle to the midpoint of the hypotenuse, then that distance is the same as the distance from the other vertex to the midpoint and the other vertex to the midpoint. So that brings us to theorem 515. It says that the midpoint of the hypotenuse of any right triangle is equidistant from the three vertices. So you start here at the midpoint. If I am right here at the midpoint of the hypotenuse, any right triangle. So here's a right triangle. If I go to the midpoint of the hypotenuse, let's say right there, then that means I am equidistant from all vertices. This was triangle XYZ. I am at that midpoint, I am equidistant to all the vertices. Okay, that's it. So if you want to have some more fun, and I'm sure you do, and we can go over this the next time, the extended learning, you like to call it homework, it's on page 187. It's just a table, really, that you have to fill in. And all you need to do is fill in this table with a bunch of check marks. So it's not too bad. All right, hope that helps.